Hello students, welcome to my channel. My name is Darshan. I'm your maths prof. We are starting a new series where I'll be covering all the chapters of IGCSE Extended Maths. In this series, we'll also cover all the questions, the kind of questions you can find in IGCSE board exams, as well as the probable questions which you may find in future in this IGCSE particular exam. Okay, so in this particular course we are starting first chapter, that is number system. Okay, so follow me here. uh, in this chapter we'll be covering classification of numbers, then there are prime factorization and HCF LCM. Then we'll see the order of operations also. Order of operation means you must have learned about the board mass in your previous grades, so that will cover here. Then how the indices, how the laws of indices are used while solving the questions in numbers, we'll see that. And then in the end, the easiest topic of this chapter, that is the rounding off, how to round off the given number in nearest 10 or nearest 100, or any given instruction. Okay, so let's start with the classification of numbers. Now you see the numbers are classified as first classification is natural numbers. Natural numbers are basically counting numbers. So if I ask you, start counting people around you, you'll always start with 1, 2, 3, 4, and so on. So all these positive integers like 1, 2, 3, 4, all these are considered as natural numbers. Then comes the whole numbers. Whole numbers are all these natural numbers, I mean 1, 2, 3, 4, 5, 6, and so on, as well as 0. Zero is also considered as whole numbers. So basically all the natural numbers are whole numbers, but not all whole numbers are natural numbers, because there is a 0 which is whole number but not natural number. Okay, so next comes integers. Integers are basically all these whole numbers, you mean 0 as well as natural numbers, and we consider negative integers also here. So it's infinite on both the sides, all the 0, 1, 2, 3, 4, and so on right hand side, as well as -1, -2, -3, and so on. All these are integers. You must have learned about it in your previous grades. Next are rational numbers. So the rational numbers are numbers which can be written in p by q form. I mean, fractional form, where p is your numerator and q is your denominator. But specifically in rational numbers, numerator, which is p, and denominator, both are integers, as well as q can never be equal to 0, because you already know that you cannot divide any number by 0. If you divide any number by 0, you'll get infinitely large number, right, which is not a determination form, so indeterminate form basically. Okay, so let's see some examples of rational numbers. All the natural numbers which we have seen, like 1, 2, 3, 4, the counting numbers, I mean. So let's say 3 can also be written as 3 upon 1, yeah, because 3 upon 1 is 3 only, so it is also a rational number. Let's say 80, so 80 upon 1 is also a rational number, correct? So all the natural numbers are rational numbers. Then the whole numbers, I mean 0 is also a rational number, because 0 divided by anything is 0, na? So 0 upon 1 is also 0, so 0 is also a rational number. Then comes negative integers like -5, -8. So -5 can be written as -5 upon 1, so it is also a rational number. Then all the fractions which you have seen in your previous grades, like proper fractions, I mean which are less than 0, sorry, less than 1 and bigger than 0, between 0 and 1 basically, so they are also rational numbers. Let me give you one example. Let's say 1 upon 2 or 1 upon 5, all these proper fractions are rational numbers. Then comes improper fractions also. Improper fraction means which are bigger than 1. So let's say 5 upon 2, or negative also, like negative 8 upon 7. Improper but negative, so they are also rational numbers. Okay, so I can say all the natural numbers and whole numbers and integers, all the fractions, all the terminating decimals. Terminating decimals means the decimals whose digits stop after certain time. Let's say for example 8 upon 8.21. So you see, after two digits, after the decimal point, only two digits are there and stops there, so that means it's a terminal decimal. And terminating decimals are rational numbers. Then non-terminating but recurring. Non-terminating but recurring, that means they are not stopping after certain digits, but they repeat the same pattern. For example 7.121212 and so on, which can also be written as 7.12 bar. So they are also rational numbers. You can also convert them into p by q form, but how to convert them in p by q form, that we'll see in I think 7th or 8th chapter. Yeah, but right now just make sure that whenever you see any non-terminating but recurring kind of decimals, they are rationals. Okay, but the third kind of decimals, which are non-terminating and non-recurring, they are not rationals. They are covered in irrational numbers. Okay, so this takes me to the next classification, that is irrational numbers. Irrational numbers are basically those are not rational, so which cannot be converted into p by q form. So not in p by q form, they are not in p by q form, or they are not be able to convert it into p by q form. For example pi. You must have heard this number pi, which we use for finding the circumference of a circle or area of a circle. That area of circle is pi r square, and circumference is 2 pi r. So all these formulas contain this number pi. And for simplification of our calculation, we take the value of pi as 22 by 7. Now if you see 22 by 7, 22 by 7 is already in p by q form. Then how pi is irrational? Or sometimes you take it in 3.14, pi as 3.14, which can also be written, this is terminating 3.14, after two digits it's terminating decimal can be converted into p by q form easily, that is 314 by 100. So 22 by 7 or 3.14, they both are rationals, but pi itself is irrational, because this 22 by 7 or 3.14, they are not the real values of pi, they are just approximate values of pi, because exact values of pi cannot be determined. You cannot find exact values of pi. Clear? So next is let me just remove this. So pi is irrational number whose approximate value must be rational, but pi itself is irrational. Then which we just discussed in the last slide, that non-terminating and non-recurring decimals. Non-terminating and non-recurring, that means they doesn't stop after certain digits, as well as they don't repeat the same pattern. So non-terminating and non-recurring decimals are also irrational. There is another number which is a Euler's number, whose approximate value is again 2.71. But this 2.71, of course, it's rational because it's terminating. But Euler's number itself, it is irrational. Its decimal expansion is non-terminating and non-recurring kind of. Okay, then comes all the square root of non-square numbers. Let's say 3. 3 is a non-square number, so if I find the square root of 3, it is irrational. Square root of 5, irrational. Square root of 6 is irrational. So that means any square root of non-square number, then same, any cube root of non-cube number. Let's say 9. 9 is a square number but not a cube number. So if I find the cube root of 9, it is irrational. Cube root of let's say 10, irrational. So that means any cube root of non-cube number is irrational. Okay, so now you understand what is irrational number. And then in the end, there's real numbers. Real numbers are all the numbers which we have learned so far. All the numbers which we have seen so far are real numbers. So basically natural numbers, integers, whole numbers, and rational, irrational, all are collectively called rational, sorry, or all are collectively called real numbers. Okay, now let's see how the natural numbers are further classified. Natural numbers are classified as either even or odd, prime or composite. Okay, even are basically multiples of 2. Multiples of 2. So all the numbers which are divisible by 2 are multiples of 2, and they are called even numbers. For example, 2, 4, 6, 8, and so on. Any multiples of 2, any alternate number starting from 2, all the alternate integers are even numbers. Okay, next are odd. Odd means those who are not multiples of 2. So that means except this even numbers, all the positive integers are called odd numbers. So for example 1, 3, 5, 7, and so on, all these are odd numbers. Then comes prime numbers. Prime numbers are numbers which have only 2 factors. So only 2 factors. Factors, you must have learnt about the factors in your previous grades. So factors are basically the numbers which are divisible, which can divide your given number. So let's say let's take one example. It's let's say 2. So 2 comes in only one table. 1 times 2 is 2. So if you see only 2 factors are there, that means it's a prime number. Another let's say 7. So it is divisible by 1 and 7 itself. So only 2 factors are there. So all these are prime numbers: 2, 3, 5, 7, and so on. Clear? Then comes the composite numbers. Composite numbers are basically not prime, so that means they have more than 2 factors. Let's say let's take one example, 36. So if I enlist all the factors of 36, I can write it like this: 1 times 36 is 36, then 2 times 18 is also 36, 3 times 12, then 4 times 9, and 6 times 6. So basically factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. So if you observe, there are more than 2 factors, right? 2 factors will always be there, like number itself as well as 1, they are trivial factors. So if any number which have more than these 2 factors, they are called composite numbers. Okay, but if you observe, if I talk about 1, then 1 is divisible by 1 only. So it doesn't even have two factors, it has only one factor. That means 1 is neither prime nor composite, neither prime nor composite. So you can call it a special number which is neither prime nor composite. Clear? So in the next slide, I'll show you how to enlist all the prime numbers. Here we are using all the numbers till 60. In your homework you can try doing the same thing till, let's say, 100. That will be useful for you. Once you get used to all the prime numbers, then in calculation it will make you it will be easier for you. Okay, so we just saw that 1 is neither prime nor composite, so let's remove that number from this list. In this list, what I'll do, I'll remove all the composite numbers as well as 1. So all the non-prime numbers I'm removing, and in the end what I'll get, they are prime numbers. So let's say 2. 2 is prime number because 2 has only two factors, 1 and 2 itself, so it's a prime number. So any multiple of 2 will have more than two factors, huh? Because 2 is also their factor, 2 is also one of their factors. So I'll remove all the multiples of 2. So that's 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, and 60. All these are even numbers, and I removed all of them. So basically 2 is the only even number which is prime. Okay, next is 3. Yes, is a prime number. So that means all the multiples of 3 are removed from this list because they are multiples of 3. So 3 is one of them, one of their factors. So one number itself as well as 3, at least 3 factors they must have. So that means let's remove them, they are not prime numbers. So 6, 9, then 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, and 60. Next is 5. So all the multiples of 5 I'll remove. So that's 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Then comes 7. 7 is a prime number. So all the multiples of 7 which are there in the list, so they are 14, 21, and 28, then 35, then 42, then 49, then 56. All these are multiples of 7 which are there in this list. They have many other multiples of also, but in the list we have the numbers till 60, so I'll consider them only. Then 11. So all the multiples of 11 are removed. They are 22, 33, 44, 55, already removed. Then 13. So all the multiples of 13, let's remove them. 26 and 39 and 54 removed. Then comes the 17. So all the multiples of 17, 17 twos are 34, 17 threes are 51, and then there are no numbers after 60. So 19, 19 multiples of 19 are 38 and 57, rest are removed. uh, 23 multiples are 46, and then next are not there in the list. Then 29, the multiples of 29 are 58, so there it's already removed. 31, there are no multiples of 31 here in the list because 31 twos are 62, which is not there in the list. So yeah, then 37, then 41, then 43, 47, and 53 and 59. All these numbers which we got are considered as prime numbers. Clear? So in next session, we'll see the second topic of this chapter, which is prime factorization and HCF and LCM. See you till then. Stay tuned for the upcoming sessions. We'll cover each and every topic of this whole course. So stay with me. Goodbye.